Welcome to Aeronet's Visual Simulation Training Program for the Airbus A320. The description of the auto flight system, known as the Flight Management and Guidance System, or FMGS, is laid out in Volume 1 of the Flight Crew Operating Manual and Volume 4, the FMGS Pilot's Guide. Volume 1 contains a general description of the system and outlines the various functions, while Volume 4 is devoted to the Flight Management Guidance System operation and pilot interface. Additionally, normal and abnormal procedures will be covered in FTD and simulator sessions. The A320 Flight Management Guidance System provides functions for navigation, lateral and vertical flight planning, performance optimization and flight predictions, and provides information to the display units. The FMGS also controls the autopilots, flight directors, and autothrust. The Flight Management Guidance System is comprised of two Flight Management and Guidance Computers, or FMGCs, two Multipurpose Control and Display Units, or MCDUs, one Flight Control Unit, or FCU, and two Flight Augmentation Computers, or FACs. MCDU 1 and 2 are located on the pedestal and are used to interface with the FMGCs for flight plan construction, monitoring, and revision. The MCDU also allows access to other aircraft systems such as ACARS and maintenance test and reporting functions. The Flight Control Unit, or FCU, located on the glare shield, has controls for short-term pilot-selected guidance and controls for the autopilot and autothrust functions. The FMGCs display flight guidance and navigation data on the two primary flight displays, or PFDs, and the two navigation displays, or Nav displays. The PFDs and Nav displays are controlled through their respective Electronic Flight Instrument System Control Panel, or EFIS panel, located on the glare shield. The thrust levers are the main interface between the pilot and the thrust control system. When the autothrust is active, engine thrust is set by the FMGS through the Full Authority Digital Engine Control, or FADEC. The thrust levers act only as thrust rating limiters and do not move as engine thrust varies. There are two types of guidance possible within the autoflight system: managed and selected. In managed guidance, the aircraft is guided by the FMGS along a pre-planned route with lateral, vertical, and speed profile computations. Selected guidance is short-term guidance selected by the pilot through the Flight Control Unit. Selected guidance always has priority over managed guidance. The two Flight Management and Guidance Computers each have two main sections: the Flight Management section and the Flight Guidance section. The Flight Management section controls the functions of navigation, which includes position computation and the automatic tuning of required navigation radios, flight planning, which includes lateral and vertical functions, the prediction and optimization of performance, and the management of the primary flight, navigation, and MCDU displays. The Flight Guidance section controls the functions of the autopilot, the flight director, and the autothrust. Each FMGC has a self-contained database which has two fields. One field, which is not modifiable by the pilot, contains navigation data for company routes, waypoints, airways, holding patterns, airports, runways, airport procedures, nav aids, fuel policy, and alternates. This field is customized to suit the individual airline and is usually updated every 28 days. A second, smaller field allows the pilot to temporarily enter and store up to 20 waypoints, 10 runways, 20 nav aids, and 3 routes. The FMGC also has an integrated performance database used by the Flight Management section to compute predictions which is not accessible by the airline or pilot. The FMGS has 3 modes of operation: dual, independent, and single. When operating in the normal dual mode, the 2 FMGCs each perform their own computations and exchange data on a crosstalk bus. Data entered into either MCDU is transferred to both FMGCs and all peripherals. In the event that one MCDU fails, all data is retained in the other. The FMGS operates in the degraded independent mode when there is a major mismatch in database or program compatibility between the 2 FMGCs. When this occurs, both FMGCs work independently and control only their on-site peripherals. A message in amber stating independent operation comes up on both MCDU scratch pads. Any entry on one MCDU is transmitted only to its respective FMGC. In order to get similar flight director autopilot orders, identical entries must be made on both MCDUs. The FMGS operates in the degraded single mode if one FMGC fails. When this occurs, the MCDU menu page appears with an FMGC timeout message. When the FMGC function prompt is selected, the MCDU screen returns with the message opposite FMGC in process. The remaining FMGC controls all peripherals, and both MCDUs control or display data from the remaining FMGC. The Nav Display associated with the failed FMGC must be set to the same range and mode as the opposite Nav Display, otherwise the message "Map not available" and select offside range mode is displayed. The MCDU menu key accesses the MCDU menu index page, which has prompts for selecting the available subsystems. To access the FMGC, press the line select key to the left of the FMGC prompt. The Aircraft Integrated Data System and the Centralized Fault Display System are normally maintenance subsystems. The MCDU screen is capable of displaying up to 14 lines with up to 24 characters in each line. The first line is the current page title. The next 12 lines are alternatively a label line followed by a data field line. Each label line names the data field line displayed directly below it. The last line on the screen is the scratch pad line. FMGC-generated messages are displayed here, as well as characters typed by the pilot on the alphanumeric keyboard. Data typed into the scratch pad is loaded into the appropriate data field by pressing the adjacent line select key. The referencing of the line select keys is 1 left to 6 left for the left-hand side and 1 right to 6 right for the right-hand side. The MCDU displays data in 2 font sizes and in various colors. The title line is displayed in large font, usually white. Label lines are displayed in small white font. Pilot entered and modifiable data in data fields is displayed in large blue font. The FMGS computed or non-modifiable data is displayed in green font. Data in the scratch pad is in large font. Amber boxes indicate that data insertion is mandatory. Blue brackets indicate that data insertion is possible but not mandatory. The clear key is used to erase FMGC messages and pilot entered data from the scratch pad or to clear data in data fields. To clear FMGC messages in the scratch pad, the Clear key is pressed once. Press the Clear key. To clear pilot entered data in the scratch pad, pressing the Clear key once will erase the last character entered. Pressing it for 3 seconds will clear all of the text in the scratch pad. Press and hold the Clear key. To clear data in a data field, the Clear key is pressed once to enunciate clear in the scratch pad, then the adjacent line select key is pressed to clear the data from the field. Press the Clear key, then line select 3 left to clear Kedge from the flight plan. The FMGS displays information on the MCDU using 3 different page types, which are accessed in various ways. The first type displays a prompt of 2 vertical arrows in the lower right corner of the display when the information is too long to fit within the screen. Scrolling the page up or down, line by line, is accomplished using the 2 slew keys. The second type displays a horizontal arrow prompt in the top right corner of the page when information is displayed on 2 consecutive pages. Pressing the next page key will sequence the pages. The third type displays a caret or star prompt when successive pages containing different types of information are available. Pressing the line select key adjacent to the prompt will access the required page. The page keys, when pressed, display the associated page required for access to flight management functions and computations and data entry. The page keys and some special function keys are briefly summarized in the following screens. Complete coverage is found in the FMGS Pilot's Guide Volume 4. The Init key accesses the Flight Plan Initialization A page, which is only available during the pre-flight phase. The pilot uses this page to insert a company routing or city pair routing, the flight number, and to align the inertial reference system. Once a routing is entered, the originating airport, latitude and longitude are displayed. Included on this page are data fields to enter the alternate airport, flight number, cost index, the initial cruise altitude with planned outside air temperature, and the tropopause altitude. There's also a prompt to access the wind history page, which allows the pilot to view and enter, if desired, the recorded wind at various flight levels during the last leg descent.
The Initialization B page has 2 mandatory data fields to complete, the 0 fuel weight and the block fuel on board. The remaining data fields are computed by the FMGCs, and if shown in blue font, can be modified by the pilot. The Init B page is not available 15 seconds after the first engine start.
The Flight Plan key accesses the Flight Plan A page, containing a leg-by-leg description of the active primary flight plan with time, speed, and altitude predictions. The top line is the from waypoint. The second line is the to waypoint, which is always displayed in white. The destination airport at the bottom of the screen is also displayed in white. Note the slew prompt arrows in the bottom right corner of the page. Since this page is too long to fit onto the screen, the up and down slew keys are used to scroll through the flight plan. Touch the slew key to scroll the flight plan 1 line. In the top right corner of the page is the next page prompt, indicating that another page is available. Pressing the next page key accesses the Flight Plan B page, which displays FMGC computed fuel predictions and interpolated winds at each waypoint. It is possible to enter forecast en route winds into the data fields using the right-hand line select keys. Pressing the airport key jumps to the last page of the flight plan, where the destination airport is shown as the last waypoint. Successive pushes of the airport key will display the alternate airport, then the destination airport again. Pushing the key before takeoff will include the originating airport in the sequence. Touch the airport key to continue. The Direct key accesses the Direct To page, which allows the flight plan to be modified by proceeding from the present position direct to any waypoint. A pair of blue brackets is displayed at line 1 left. The new waypoint can be typed into the scratch pad, then entered using the line select key 1 left, or it can be selected directly from within the body of the current flight plan by pressing the line select key adjacent to the desired waypoint. Touch the line select key 3 left to proceed direct to Kedge. The Overfly key is used to allow the aircraft to overfly a selected waypoint. Normally, the aircraft does not fly directly over a waypoint to avoid overshooting the next leg, especially when a large track change is required. If required to overfly a waypoint, the Overfly key is pressed once to display an overfly triangle in the scratch pad. Then the line select key adjacent to the waypoint to be overflown is pressed to insert the triangle at the selected waypoint.
The Prog key accesses the progress page corresponding to the current active phase of flight. This page displays the cruise, optimum, and recommended maximum flight levels. The FMGS bearing and distance to any airport, waypoint, nav aid, or runway can be checked by entering its position into the brackets. As well, the FMGC position can be updated if required. The bottom of the page, which will be covered later, indicates whether the navigational accuracy of the FMGS is high or low, and displays the auto-tuned or manually tuned VOR stations. Auto-tuned VORs are displayed in small blue font, and manually tuned VORs are displayed in large blue font. In the descent phase, descent monitoring information is also available.
The Perf key accesses the performance page corresponding to the current active phase of flight. The current flight phase is displayed with a green page title. The various flight phases can be accessed by selecting the next or previous prompts. Other flight phases have a white page title. The performance pages available are takeoff, climb, cruise, descent, approach, and go-around. These pages display the calculated optimum speeds or Mach number, along with other predictions and information. Once a flight phase has already been flown, that performance page is no longer available. The Data key calls up the Data Index page, which allows access to various reference pages. The pages available from 1 to 4 left allow for review of database, waypoints, nav aids, runways, and routes, and are not modifiable by the pilot. Lines 1 right to 4 right allow the creation and review of pilot-stored waypoints, nav aids, runways, and routes. Line 5 right is the aircraft position monitor, which displays FMGC computed aircraft position. Line 5 left selects the aircraft status page, which gives the validity period of the active and secondary databases. On the ground, the secondary database can be selected as the active database if required. However, pilots are cautioned never cycle the databases in flight, as all flight plans and stored data will be erased. The RAD nav key accesses the radio navigation page. This page displays the nav aids that have been tuned automatically through the FMGC and allows the crew to manually tune navigation aids and enter the required courses. When tuning manually, enter the ident rather than the frequency if the nav aid is in the database. Manually tuned nav aids are displayed in large blue font.
The Fuel Predict key accesses the fuel prediction page. This page displays the fuel predicted to be remaining at destination and at the alternate, along with other fuel management data. After the first engine has been started, if advised of a change to the gross weight and C of G, the updated information will have to be entered on this page, since access to the init B page is not available 15 seconds after the first engine has been started.
The Secondary Flight Plan key accesses the Secondary Flight Plan Index page. The Secondary Flight Plan is normally constructed starting with a copy of the active flight plan, then modifying it to prepare for example, possible runway changes or en route diversions. There are prompts to copy the active flight plan into the secondary flight plan, to access and modify the secondary flight plan, to delete the secondary flight plan, and to activate the secondary flight plan as the active flight plan. The MCDU scratchpad will also display specific messages generated by the FMGC. Higher priority messages are displayed in amber and cover navigation messages, data entry errors, and Nav Display repeat messages. White messages are advisory only. Messages can be cleared using the Clear key. A list of all MCDU messages is contained in the FMGS Pilot's Guide, Volume 4, Chapter 3, MCDU Messages. There are 3 annunciators located on the left and right side of the MCDU keyboard. The Fail annunciator, displayed in amber, indicates that the MCDU unit has failed. The MCDU menu annunciator, displayed in white, requests that the pilot call up a system that is linked to the MCDU, such as ACARS or the Centralized Fault Display System. The FMGC annunciator illuminates when the crew is using one of the other peripherals, such as ACARS, and the FMGC has an important message to deliver. To display the message in the scratchpad, the crew must return to the FMGS display by pressing the MCDU menu key followed by the line select key adjacent to the FMGC prompt. The brightness knob controls the brightness of the MCDU display but does not allow the MCDU to be switched off. To review, the various MCDU screen prompts include an arrow in the upper right corner indicating that a next page is available using the Next Page key. Up and down arrows in the bottom right corner indicate the data on the screen is too long for the display and can be scrolled up or down using the slew keys. Left or right carets indicate another page may be selected using the adjacent line select key. Amber boxes to indicate mandatory data entry. Data lines for entry of data by FMGC or pilot. Square brackets indicate that data insertion is possible but not mandatory. An arrow adjacent to a line select key indicates pressing the associated line select key will activate the prompt or select data. The Flight Control Unit, or FCU, located on the glare shield, can be broken down into 3 separate control areas with their own selector knobs, display windows, and in the lateral and vertical areas, mode engagement push buttons. There are also 3 additional push button switches for the autopilots and auto thrust.
The FCU allows two types of guidance, selected or managed. Selected or short-term guidance is selected by turning a control knob to set the desired value in the display window, then pulling out on the control knob. Managed guidance, which gives control to the FMGS, is engaged by pushing in on a control knob. In managed guidance, the display window associated with that mode displays dashes, and the white managed dot next to the window illuminates. Selected guidance always has priority over managed guidance. The Speed Mach Selector knob, when turned, will set the selected speed or Mach, and when the knob is pulled, will select the desired speed or Mach. The PFD speed scale displays the target speed as a blue triangle. In selected speed, the switching of a speed target to a Mach target and vice versa is automatic. However, the Speed Mach push button allows the pilot to select speed or Mach at his option. When the Speed Mach Selector knob is pushed in, managed speed is engaged, indicated by a dash line in the display window, and the illumination of the managed speed Mach dot. The PFD speed scale displays the target speed as a magenta triangle.
The heading selector knob, when turned and pulled, is used to set a selected heading. This is indicated as heading in the lateral mode column of the FMA. The heading selector knob, when pushed in, arms or engages managed nav mode. On the FMA, managed nav arming is indicated in the lateral mode column, second line, by the legend nav in blue, and the managed lateral dot illuminates on the FCU. When managed lateral nav engages, nav appears on the FMA in green, and dashes are displayed in the heading window of the FCU. Pushing the localizer push button arms, engages, or disengages the localizer only. The green light in the push button illuminates, and when armed, LOC appears in blue on the second line of the FMA. When engaged, LOC appears in green. The vertical speed selector knob, when turned, sets a vertical speed value into the display window. The vertical speed range is from minus 6,000 feet per minute to plus 6,000 feet per minute in 100-foot increments. Pulling out on the selector knob then engages vertical speed mode. The FMA displays vertical speed in green with the set vertical speed value in blue. Caution: it is possible to select vertical speed without having first armed a lower altitude. Pushing in on the vertical speed selector knob will engage a vertical speed of 0. The FMA vertical mode column will display vertical speed 0, and the vertical speed window on the FCU will display zeros.
The heading vertical speed track flight path angle push button is used to change heading reference to track reference in the FCU heading track window and vertical speed reference to flight path angle reference in the FCU vertical speed flight path angle window. Touch the heading vertical speed track flight path angle push button. The flight path angle range is from minus 9.9 degrees to plus 9.9 degrees in 0.1 degree increments. The PFD flight director indications also change from the pitch and roll crossbar display to the flight path director flight path vector display. The track flight path angle is normally used for non-precision approaches that are not stored in the database. The altitude selector has an inner and an outer knob. The outer knob has two positions, 100 and 1000. When set to 100, the inner knob changes the altitude setting in increments of 100 feet. It is normally used in the terminal area. When set to 1000, the altitude setting changes in increments of 1000 feet. Once a new altitude has been set, if the knob is pulled out, the aircraft will start in immediate unrestricted open climb or open descent, depending on whether the new altitude is above or below the current altitude. Open climb or open descent is enunciated in the second column of the FMA, and a blue Alt armed indication is displayed below it. The new setting is also displayed on the PFD altitude scale.
When in Manage Navigation, if the altitude selector knob is pushed in, the Manage dot illuminates and the aircraft immediately begins a managed climb or managed descent, again depending on whether the new altitude is above or below the current altitude. All vertical constraints contained in the MCDU flight plan are considered. Climb or descent is enunciated on the FMA. The alt-armed indication is displayed in blue because the first vertical constraint altitude must be set in the FCU altitude window. The FCU altitude window is never blank and always displays the value set by the pilot.
The Expedite push button is pressed to engage the Expedite mode of climb or descent. The green light in the push button illuminates, and Expedite climb or Expedite descent is enunciated on the FMA. Expedite mode is a temporary open mode and orders the aircraft to climb at green dot speed, the best lift-to-drag ratio speed, if the FCU altitude is set to an altitude higher than present aircraft altitude, or to descend at 340 knots, Mach 0.80, if the FCU altitude is set to an altitude lower than present aircraft altitude. Expedite mode is further explained later in this module. The approach push button is used to arm the localizer and glide slope modes if an ILS approach is selected in the active flight plan. The approach push button also engages the approach nav final mode if a non-precision approach is selected in the active flight plan. The green light illuminates in the push button. When armed, glide slope and loc appear on the FMA in blue for an ILS approach and final approach nav in blue for a managed non-precision approach. The indications turn green as each mode engages.
The Autopilot 1 and Autopilot 2 push buttons are used to engage or disengage the autopilot functions. While they can also be used to disengage the autopilots, the standard procedure used to disengage the autopilot is to press the takeover push button on the side stick. The autopilot push button light illuminates in green when the autopilot is engaged, and the fifth column of the FMA displays autopilot in white. Only one autopilot can be engaged at a time, except that when the ILS approach mode is armed or engaged, both autopilots may be engaged. The autothrust push button is used to arm, activate, or disconnect the autothrust, although the standard procedure used to disconnect the autothrust is by pressing the instinctive disconnect push button on the thrust levers, or by setting both thrust levers to the idle detent. The autothrust push button light illuminates green when the autothrust is either armed or active. The fifth column of the FMA shows autothrust in blue when armed and in white when active.
Pressing the ECAM meter selector push button displays the present FCU target altitude on the lower ECAM display in meters. The altitude value, displayed in the FCU altitude window, is always displayed in feet, regardless of the push button selection. The flight management section of the FMGC performs four main functions, which are navigation, flight planning, both lateral and vertical, performance optimization, including predictions, and the management of the display units. The navigation functions of the FMGC include the computation of aircraft position, the evaluation of position accuracy, the tuning of navigation radios, and the alignment of the inertial reference system. The FMGC uses two sources to compute aircraft position, which is referred to as the FM position. The FM position is calculated from a mixed inertial reference system position, corrected by a radio position, and in flight, approaches or favors the radio position. The Mixed Inertial Reference System, or IRS position, is the average position as calculated by the three IRSs. The three IRSs are continually monitored, and if a unit is out of limits, it is rejected. The radio position is determined by the use of nav aids tuned automatically by the FMGC. The first priority is to use two DMEs, but if not available, the second choice is a VOR DME. During an ILS approach, it also uses the localizer beam to determine lateral position. The Selected Nav Aids page displays the automatically tuned nav aids. The Selected Nav Aids page is accessed by pressing the Data Page key, line selecting the Position Monitor prompt at 5 right, then line selecting the Nav Aids prompt at 6 right. Line 1 left displays the nav aid tuned for display on the pilot's nav display. Lines 2 left, 3 left, and 4 left display the nav aids tuned by the FMGC for radio position updating. On the ground before takeoff, the FM position is a mixed IRS position only, using the departure airport coordinates stored in the database as a reference. At takeoff, when the thrust levers are advanced to the takeoff position, the FM position is updated to the database departure runway threshold. In flight, the FM position is refined by radio position updating. The FMGC continually computes the difference between the mixed IRS position and the radio position. This is referred to as the bias. In an area where there are no nav aids available for radio updating, the FMGC applies this bias to the mixed IRS position to calculate the FM position. The bias remains constant until radio position updating is restored. The Position Monitor page displays the various position computations. It is accessed by pressing the Data key, then line selecting the Position Monitor prompt at 5 right. The Position Monitor page displays the FM position of the onside and opposite FMGCs, the radio position, and the mixed IRS position. The data at line 5 displays the deviation of each IRS from the onside FM position in nautical miles. Line selecting the freeze prompt at 6 left will freeze the data displayed on the page for ease of comparison. The FMGS continually estimates how far the aircraft FM position drifts. Position drift, or position error, is a function of radio updating availability and accuracy. With radio updating, the FM position error is estimated to be small. If there is no radio updating available, then the FM position error is estimated to slowly increase over time. The value of the FM position error is not displayed to the crew, but is displayed on the prog page as either high or low navigational accuracy. The Nav Accuracy Limits are defined by airworthiness authorities for various flight environments. The limits are approximately 3 miles en route, 2 miles in the terminal area, and up to 0.6 miles in the approach area. If the estimated FM position error is within these limits, the prog page displays the accuracy as high. If the estimated FM position error is outside these limits, then the accuracy indication is low. If the accuracy level changes from high to low, then both the Nav Display and the MCDU display the message Nav Accuracy Downgrade. Likewise, changing from low to high will generate the message Nav Accuracy Upgrade. Since FM nav accuracy is based on an estimated position error, the flight crew must periodically check aircraft position against raw data. On the Nav Display, the FM distance to the two-way point can be checked against raw data if the two-way point is a VOR DME. Manually tune, if required, then display the same VOR DME with the EFIS control panel select switch and simply compare the distances. The nav accuracy can also be checked on the prog page by inserting into the bearing and distance field the same NavAid ident as the one tuned at line 6. Compare the raw data DME on the Nav Display to that in the bearing and distance field of the prog page. The navigation radios are tuned for two different purposes: display on the pilot's nav display and for FMGC radio position computations. For display, the NavAids can be tuned automatically by the FMGC and manually by the pilot through the MCDU RadNav or prog pages, or, in case of failure, through the radio management panels. For FMGC radio position computations, the NavAids are tuned automatically by the FMGCs. These are shown on the selected NavAids page. Each FMGC auto-tunes one ILS before takeoff when an ILS is associated with the takeoff runway, and in flight when the flight plan contains an ILS approach. One ADF is auto-tuned if the flight plan contains a database NDB approach, but only when the aircraft is approaching the first fix of the approach. Therefore, it is mandatory to manually tune the ADF sooner in preparation for the approach. Alignment of the inertial reference system by the FMGS may only be accomplished on the ground before takeoff. The alignment process is initiated when each inertial reference selector switch is moved to the nav position. A normal alignment takes approximately 10 minutes. During this time, the IRS, using laser sensors and accelerometers, senses the Earth's rotation and local gravity to determine aircraft heading and an estimated latitude. The time remaining to alignment is displayed on the upper ECAM memo section. Touch the IRS selector switches to initiate the alignment process. The alignment process cannot be completed until the crew enters a company route or the originating destination city pair into the Init A page, then selects the Align IRS prompt at 3 right. The departure airport reference coordinates contained in the database are then sent to the inertial reference unit. They are compared to the position of the aircraft when it was last powered down and to the IRS computed latitude, and, if within limits, the alignment process will continue to completion. The company route has already been entered into the MCDU. Touch the Align IRS prompt at 3 right, then the right arrow to continue.
A fast alignment used at stopovers when time is limited takes approximately 3 minutes. When a new company route or city pair is entered into the MCDU, the message Reset IRS to Nav appears in the scratch pad. The fast alignment is initiated by moving all 3 IRS mode selector switches from Nav to off, then returning all 3 selector switches back to Nav again within 5 seconds. All computed speeds are reset to 0, and the aircraft position is refined. The company route has already been entered into the scratch pad. Touch all 3 IRS mode selector switches to switch them off. Touch all 3 again to select Nav. Then touch the Align IRS prompt on the MCDU to initiate a fast alignment.
Another function of the flight management section is flight planning. The FMGS is capable of containing 2 flight plans, the active flight plan and the secondary flight plan. The active flight plan includes both the lateral flight plan, which provides horizontal flight path information, and the vertical flight plan, which provides the speed and altitude profile. The MCDU and navigation displays, nav aid tuning, performance, and fuel planning are all based on the active flight plan. To access the secondary flight plan, touch the secondary flight plan data key, then the secondary flight plan line select key at 2 left. The secondary flight plan is used to prepare for a possible change in the departure or arrival runway, to plan a diversion, or to prepare the next flight leg. Normally, it is a copy of the active flight plan upon which modifications can be made. It is displayed in white on both the MCDU and the Nav Display and can be activated at any time. The lateral flight plan defines the intended horizontal flight path and is composed of 4 elements: the departure, the en route phase, the arrival, and the alternate flight plan. The departure includes the takeoff runway, a standard instrument departure, and an en route transition if required. The en route phase includes airways and waypoints. The arrival includes any en route transitions, standard arrival routes, the landing runway with the selected approach and any missed approach procedures. The alternate flight plan includes the routing to the alternate. Lateral revisions may be made to the flight plan by using the left line select keys. Entering data into a lateral revision page creates a temporary flight plan which is displayed in yellow on the MCDUs and the nav displays. This provides an opportunity to review the flight plan before inserting it into the active flight plan. In this example, Jet 504 to VBI has been entered into the VIA Go-To field to create a temporary flight plan. Touch Line Select key 6 right to insert the temporary flight plan into the active flight plan. A lateral revision at the originating airport allows the selection of the departure runway, SIDS, and departure transitions, and to modify the flight plan by selecting a next waypoint or new destination. A lateral revision at the from waypoint allows the pilot to enter a lateral offset of from 1 to 50 miles to the left or right of the active flight plan. When entering an offset distance into the scratch pad, an L or an R must either come before or follow the entered number. Access to the hold pages is also available at the from waypoint in order to enter an immediate hold at the present position. A lateral revision from a waypoint allows the modification of several waypoints or the routing using the VIA Go-To, Next Waypoint, or the New Destination fields. Access to the hold pages and the ability to enable the alternate flight plan is also available. A lateral revision at the destination airport allows the selection of the arrival approach and runway, stars, approach vias, and en route transitions, if any. Prompts are also available to enable the alternate flight plan and to review and/or change the alternate airport or routing. There are 2 other methods to revise or modify the lateral flight plan. In both cases, a temporary flight plan is not created. The first method is to proceed from the present position direct to a waypoint by using the Direct key. The desired waypoint can be line selected from within the body of the current flight plan, or it can be entered into the scratch pad, then line selected into the Direct To field. Touch the Direct key, then line select. The second method is to type a waypoint into the scratch pad, then left line select it directly over top of an existing waypoint. In this example, the flight plan shows VLR is the waypoint after VLN. ATC has recleared you to proceed VLN direct YBR direct YQT. YBR has already been entered into the scratch pad. touch the Line Select key 3 left to enter it into the flight plan. A gap or discontinuity is created in the flight plan between YBR and VLR, and all previously existing waypoints are retained and moved down. The flight plan must be cleaned up by removing the unnecessary waypoints and the discontinuity using the Clear key. Touch the Clear key, then line select VLR. Now, touch the Clear key, then line select VBI. The vertical flight plan defines the intended speed and altitude profile and provides data to the FMGS for performance and prediction calculations. The data is entered either automatically from the database upon flight plan initialization or manually by the pilot. The vertical flight plan includes the following phases: pre-flight, takeoff, climb, cruise, descent, approach, go-around, and done. All phases except pre-flight and done have speed profiles which calculate an optimum or econ speed and altitude profiles based on the flight plan vertical constraints. Vertical revisions to the flight plan may be made by using the right line select keys. A vertical revision at the originating airport allows the pilot to modify or remove the climb speed limit and to make a wind entry. From any climb, descent, or approach waypoint, a speed or altitude constraint can be entered or the wind entry may be modified. A vertical revision to the destination airport allows entry for destination QNH and true wind. These entries are transferred to the perf approach page. From a cruise waypoint, the step predict legend appears. Once a step climb or descent altitude is entered, the predictions are computed for the start of climb or descent and the top of climb or descent and are displayed on the MCDU and Nav Display. An updated wind entry can also be made at a cruise waypoint. The flight management performance function optimizes speed in order to minimize cost. It computes the optimum speeds for takeoff, climb, cruise, descent, approach, and go-around. Calculations for optimum flight level and optimum descent profile are also calculated. It does this using the Integrated Performance Database of the FMGC and gross weight, cost index, wind, and temperature models, and a performance factor. Speeds for V1, VR, and V2 must be entered manually by the pilot from data obtained from the airline's takeoff performance system calculations. The flight management performance function also computes predictions for the flight plans and displays them on the Nav displays and the MCDUs. Predictions are based on gross weight, C of G, position, altitude, speed, wind, temperature, and autopilot and flight director mode. Predictions assume that the aircraft will fly the planned lateral and vertical flight plan. Predictions displayed on the Nav display include start of climb or top of descent, and top of climb or bottom of descent symbols, speed and altitude constraint symbols, and the deceleration point symbol. Predictions displayed on the MCDU include pseudo waypoints such as top of climb and top of descent, time, speed, altitude predictions and constraints, and fuel predictions. The flight management section of the FMGC is also responsible for the management of display units. Information on navigation, performance, predictions, and guidance is displayed on the MCDUs and the primary flight and navigation displays. The FMGC displays the following information on the PFD: armed and engaged modes on the Flight Mode Annunciator or FMA, FMGS computed targets for speed, altitude, and heading, deviation from optimum descent profile, messages if any, and navigational guidance through the flight director. The Nav Display displays aircraft position, active, temporary, and secondary flight plans, deviation from the active flight plan, wind information, the type of approach selected, messages if any, and EFIS panel selected nav information. The Flight Guidance section of the FMGC controls the operation of the flight directors, the autopilot, and the auto-thrust system.
The flight directors display guidance commands from the FMGC, which must be followed by the pilot in manual flight or used as a cross-check during autopilot operation. When operating normally, Flight Director 1, which is controlled by FMGC1, is displayed on PFD1. Flight Director 2, which is controlled by FMGC2, is displayed on PFD2. The legend, 1FD2, being displayed on the FMA of PFD1 and PFD2, confirms normal operation.
The flight directors engage automatically upon FMGC power-up when on the ground. However, the crossbars are not visible. The pitch bar becomes visible when takeoff thrust is applied, and the roll bar becomes visible soon after liftoff. The flight director push button displays a green light when the flight director is on. The flight directors can be selected on and off any time by pressing the flight director push buttons on the EFIS control panel. If one flight director is turned off in flight, the flight director bars on that side disappear. If both flight directors are turned off while an autopilot is engaged, the flight director bars disappear, but the autopilot remains engaged in the active modes. If both flight directors are turned off with the autopilots off, the flight director bars disappear, the lateral and vertical modes disengage, and the auto thrust, if on, reverts to or remains in speed mode. If the flight directors are selected on in flight with the autopilot off, they engage in the basic modes of heading vertical speed or track flight path angle. The flight director bars will flash for 10 seconds. The flight directors are displayed in 3 different ways. The horizontal and vertical crossbars show pitch and roll commands when the aircraft is in flight. During takeoff and landing, both on the ground and in flight, when the aircraft is below 30 feet, if a localizer signal is available, the vertical bar is replaced with a yaw bar for lateral steering commands. The crossbars can be changed to a flight path vector, flight path director display by pressing the heading vertical speed, track flight path angle push button on the FCU. This mode is used for non-precision approaches that are not stored in the database and allows the pilot to fly a track and to select a pseudo-glide path or flight path angle from the final approach fix down to the runway threshold. The flight path vector displays the track and flight path angle actually being flown. It must be superimposed over the flight path director to fly the required flight path.
In the event that one flight director or one FMGC fails, the remaining valid flight director is automatically displayed on both pilots' PFDs. The valid flight director is also enunciated on the FMA of both PFDs, as in this example 1FD1.
The pitch bar is automatically removed if there is no vertical mode engaged, and the roll bar is removed if there is no lateral mode engaged. The flight directors are automatically removed from view if the aircraft pitch is greater than 25 degrees up or 13 degrees down, or if the bank angle is greater than 45 degrees. The flight director bars flash for 10 seconds if, when in approach mode, the flight directors revert to heading or vertical speed mode, either automatically or manually through pilot action on the FCU. The aircraft is on the approach with the glide slope and localizer engaged. Pull out on the heading track selector knob and observe the flight director bars. The pitch and/or roll bars will flash continuously if the glide slope signal and/or the localizer signal is lost during an approach. The flight guidance section of the FMGC controls the operation of the autopilot. The autopilot reduces pilot workload by positioning the flight control surfaces according to managed commands from the FMGC or selected commands from the FCU. The autopilot can be engaged in flight 5 seconds after liftoff and is capable of performing an automatic landing with a rollout or a go-around. The FMGCs control the aircraft through the autopilot by sending commands to the Flight Augmentation Computers, or FACs, which control the rudder and yaw damper, and to the Elevator Aileron Computer, or ELACs, for control of the elevator and ailerons. The ELACs also send commands to the Spoiler Elevator Computers, or SECs, which control the spoilers and elevator, and to the Brake and Steering Control Unit, or BSCU, for autopilot control of the nose wheel on the ground. The autopilot can be engaged after the aircraft has been in the air for at least 5 seconds by selecting either the Autopilot 1 or 2 push button on. When an autopilot is engaged, the light on the Autopilot push button illuminates in green, and the FMAs display Autopilot 1 or Autopilot 2 in white, corresponding to the engaged autopilot. Only one autopilot can be engaged at a time, and pressing the other autopilot push button disengages the first, except for an ILS approach after the approach push button has been pressed. The second autopilot can be engaged. This provides a fail operational Cat3 dual capability. When an autopilot is engaged, it engages in the active flight director mode if a flight director is on, or in the basic mode of heading vertical speed, or track flight path angle if there were no flight directors selected on. With one autopilot engaged, the associated FMGC controls the flight controls. With both autopilots engaged, FMGC-1 controls the flight controls with FMGC-2 in standby, automatically taking control in the event that FMGC-1 fails. The autopilot is normally disengaged by pressing the Autopilot Disconnect Takeover push button on the side stick. Touch the Autopilot Disconnect push button to disengage the autopilot. All oral and visual warnings are temporary. The master warning flashes for a maximum of 3 seconds, the cavalry charge sounds for a maximum of 1 1/2 seconds, and the red autopilot off message is displayed on the ECAM for a maximum of 9 seconds. Pressing the Autopilot Disconnect push button a second time, or pressing the master warning light switch immediately extinguishes all oral and visual warnings, including the ECAM warning.
The autopilot also disengages if the autopilot push button on the FCU is pressed. The side stick or rudder pedals are moved with a force greater than the set pressure threshold. During a managed non-precision approach when reaching MDA minus 50 feet, if an MDA has been entered into the MCDU, or when reaching 400 feet above ground level if no MDA has been entered into the MCDU.
The autopilot will also disengage with an aircraft overspeed, if, depending on weight and configuration, the angle of attack becomes excessive, or the bank angle becomes greater than 45 degrees.
If the autopilot is disengaged by any means other than with the Autopilot Disconnect push button on the side stick, the aural and visual warnings continue until canceled by the pilot. Pressing either the Autopilot Disconnect push button or the master warning light switch extinguishes the master warning light and the aural warning. The ECAM warning must be cleared by pressing the clear button on the ECAM control panel. Press the master warning light switch or the Autopilot Disconnect push button to extinguish the master warning light and the aural warning. Press the clear button on the ECAM control panel The third function of the FMGC guidance section is auto thrust control. When the auto thrust is active, the aircraft's thrust is controlled automatically by the FMGC to maintain a specific thrust, such as climb or idle, or to maintain a speed or Mach. On takeoff, the auto thrust is armed automatically through the FMGC when the thrust levers are set to a takeoff position, either flex or toga. The green light illuminates on the FCU auto thrust push button, and the blue auto thrust message appears in the right-hand column of the FMA to indicate it is armed. Auto thrust becomes active when at the acceleration altitude, normally 1,500 feet, the thrust levers are selected to the climb detent with both engines operating, or to the MCT position with only one engine operating. This is indicated by the auto thrust message on the FMA turning white. With auto thrust active, the FMGC computes the thrust required according to demands from the MCDU and/or the FCU, then transmits this data to the Full Authority Digital Engine Control, or FADEC, via the FCU. FADEC then controls the fuel flow in order to achieve the desired N1. The thrust lever acts only as an N1 upper limit, which FADEC computes and displays on the upper ECAM. These limits are climb, with both engines operating, and MCT, with one engine inoperative. With auto thrust active, the thrust levers remain fixed and do not move as engine thrust varies between idle and the upper N1 limit. In flight, with both engines operating, setting the thrust levers forward of the climb detent gives an immediate increase in thrust and deactivates the auto thrust, but it remains armed. The auto thrust message on the FMA changes to blue to indicate it is still armed. The auto thrust is reactivated as soon as the thrust levers are set back to the climb detent, as indicated by the white auto thrust message.
With both engines operating after the acceleration altitude has been reached, the climb detent is the normal operating position of the thrust levers when the auto thrust is active. If the thrust levers are set above or below the climb detent, lever climb flashes in white to remind the crew to return the thrust levers to the climb detent when appropriate. The auto thrust message turns blue to indicate the auto thrust is still armed. Touch the thrust levers to return them to the climb detent.
The auto thrust operates in 3 modes, depending on the current autopilot flight director mode. The auto thrust modes are thrust mode, speed Mach mode, and retard mode. In thrust mode, the engine thrust is set to a specific thrust level, while the autopilot flight director pitch mode maintains a commanded speed or Mach. The possible thrust levels, which correspond to the thrust lever position, are MCT, the maximum single-engine climb thrust, climb, the 2-engine maximum climb thrust, idle, the minimum idle thrust, and thrust when the thrust levers are neither in the climb nor MCT detent. The autothrust operates in speed Mach mode to maintain either a selected or managed speed Mach, while the autopilot flight directors command a vertical profile such as vertical speed, flight path angle, altitude hold, or glide slope. The retard mode is available only when an autoland is performed. At approximately 40 feet radio altitude during the flare, the autothrust automatically sets idle thrust. At approximately 10 feet radio altitude, the oral call-out retard is generated to remind the pilot to move the thrust levers to the idle position in order to confirm thrust reduction and prepare for the selection of reverse thrust. Note, the thrust has already been set to idle. When the oral call-out retard is heard, touch the thrust levers to move them to the idle position.
Retard.
If the landing is performed with the autopilot off, speed mode rather than retard mode remains active during the flare. The oral warning retard is generated at 20 feet radio altitude, and the pilot must reduce the thrust manually by setting the thrust levers to idle. When the oral call-out retard is heard, touch the thrust levers to move them to the idle position.
Retard.
If it is necessary or desired to disconnect the autothrust, the normal method is to push an autothrust instinctive disconnect push button located on the sides of the thrust levers, setting both thrust levers to the idle detent, or depressing the autothrust push button located on the FCU glare shield panel also disconnects the autothrust. Caution: if the instinctive disconnect push button is held for more than 15 seconds, the autothrust system is disconnected for the remainder of the flight. Press the instinctive disconnect push button to disconnect the autothrust. When the autothrust is disconnected by pressing the instinctive disconnect push button or above 50 feet radio altitude by setting the thrust levers to idle, a temporary caution is triggered. The caution consists of the master caution light illuminating for a maximum of 3 seconds, a single chime, and an ECAM auto thrust off message for up to 9 seconds. Pressing the instinctive disconnect push button or the master caution within the caution time cancels the master caution light and the ECAM message. Press the master caution light or the instinctive disconnect push button to cancel the master caution light and the ECAM message. Press the autothrust push button on the FCU panel to disconnect the autothrust. When the autothrust is disconnected by pressing the autothrust push button on the FCU or by an autothrust failure, the caution remains until canceled by the pilot. Pressing either the instinctive disconnect push button or the master caution light switch extinguishes the master caution light but not the ECAM message. Pressing the clear button on the ECAM control panel extinguishes the master caution light and the ECAM message. Press the master caution light switch, then the clear button on the ECAM control panel to cancel the master caution light and the ECAM caution. When the autothrust is disconnected with the autothrust push button on the FCU, with the instinctive disconnect push button, or due to failure, the amber thrust lock message flashes in the first column of the FMA. The thrust is locked at its current setting and will not change until the pilot takes manual control of the thrust levers and moves them out of the climb detent. If the autothrust has been disconnected in flight, it can be rearmed by pressing the autothrust push button on the FCU. If the thrust levers are within the autothrust active range when the push button is pressed, The auto thrust becomes active in the current Autopilot Flight Director mode. Press the Auto Thrust push button on the FCU. The Flight Management Guidance System guides the aircraft in lateral, vertical, and common Autopilot Flight Director modes.
Pulling the Heading Track Selector knob on the FCU selects Heading or Track Mode, which guides the aircraft along the heading or track selected by the pilot. The Heading Track window displays the selected heading, and the FMA displays either heading or track in the FMA Lateral Mode column.
The Autopilot Flight Director Lateral Managed Nav Mode guides the aircraft along the flight plan contained in the MCDU. Lateral Managed Mode is armed by pressing in on the Heading Track Selector knob. The Managed Lateral dot illuminates on the FCU, and nav is displayed in blue on the second line of the Lateral Mode column of the FMA to indicate Managed Nav is armed. When Managed Lateral Nav engages, the FMA displays nav in green and dashed lines appear in the heading display window of the FCU.
The FMGC computes an intercept point and displays it on the nav display. The present aircraft track must intercept the flight plan before the two-way point, otherwise an intercept point will not be computed and displayed. The two-way point is displayed in white on the second line of the MCDU flight plan page. Managed Nav Mode also engages at 30 feet radial altitude after takeoff to fly a managed departure if armed on the ground before takeoff. The Lateral Localizer mode is armed or engaged by pressing the Loc push button on the FCU panel. It is used to intercept a localizer independent of the glide slope when a localizer-only approach is being flown. A localizer-only approach is flown using flight path angle.
The Autopilot Flight Director vertical modes guide the aircraft in the vertical plane. To change altitudes, the Altitude Selector knob on the FCU must be turned to select the new altitude, then either pushed in to engage a managed climb or descent, or pulled out to select an open climb or descent, depending on whether the new setting is above or below the current aircraft altitude, or the Vertical Speed Flight Path Angle knob may be turned and pulled out to select Vertical Speed Flight Path Angle mode.
The Climb mode guides the aircraft in a managed climb, taking into consideration any altitude constraints, as well as speed constraints if managed speed is engaged. To initiate a managed climb, an altitude higher than the present aircraft altitude is entered into the altitude window and the altitude selector knob is pushed in. The auto thrust sets maximum climb thrust and the climb commences at the selected or managed speed. The FMA displays climb in the vertical mode column and the managed level change dot on the FCU illuminates. A managed climb may contain several segments. If the next level off segment is the FCU selected altitude, the armed alt indication is displayed in blue on the second line of the FMA and on the PFD altitude scale. If the next level off segment is an altitude constraint, alt is displayed in magenta on the FMA, and the altitude constraint is displayed in magenta on the PFD altitude scale. When level at a constraint altitude, the auto thrust manages speed. Alt is displayed in magenta in the vertical mode column of the FMA. The target altitude symbol on the altitude scale is also magenta. Climb mode arms automatically for the next climb segment, as can be seen on the second line of the vertical mode column, then automatically engages when the constraint point is passed. In this example, the next level off altitude is the FCU selected altitude. Therefore, flight level 330 is displayed in blue in the top of the altitude scale. Open climb mode is a selected mode and is engaged by first selecting an altitude higher than the present aircraft altitude, then pulling out on the altitude selector knob. The auto thrust sets maximum climb thrust, and the autopilot flight director uses pitch to maintain the target speed. The open climb mode does not take any altitude constraints into consideration. Since the next level off altitude is the FCU selected altitude, Alt is displayed in blue on the second line of the FMA and on the PFD altitude scale. The Managed Descent mode provides vertical guidance while taking into consideration both the lateral and vertical flight plans, wind, and the descent profile. The descent mode is engaged by selecting an altitude lower than the present aircraft altitude, then pushing in on the altitude selector knob. The level change dot on the FCU illuminates, and the vertical speed flight path angle window displays dashes. Managed lateral nav must also be engaged before descent mode will engage. If the next level off altitude is an altitude constraint, Alt is displayed in magenta on the FMA, and the constraint altitude is displayed in magenta on the PFD. When the aircraft levels off at the altitude constraint, the FMA displays Alt in magenta. Descent mode automatically arms and engages when the constraint point is passed. If the next level off altitude is the FCU selected altitude, as in this example, the armed altitude indication at the bottom of the altitude scale is blue. The descent profile is computed from cruise level down to the decel point, where deceleration begins to reach minimum approach speed, or VAP, at 1,000 feet above touchdown and includes any speed and/or altitude constraints. The nav displays display a top of descent arrow where the FMGC calculates the top of descent point to be, and a level off arrow where the FMGC calculates the aircraft will level off. The level off arrow is blue where the aircraft will reach the FCU selected altitude, and magenta for an altitude constraint. An altitude constraint symbol circles its associated waypoint. It will turn amber if the constraint point is predicted to be missed.
When the descent mode is engaged at the top of descent point, the aircraft starts an immediate descent at idle thrust. The FMA displays thrust idle in the auto thrust column and descent in the vertical mode column.
When the descent mode is engaged before the top of descent point, the aircraft starts an immediate descent, but at a constant vertical speed of 1,000 feet per minute until it intercepts the computed descent profile. If the aircraft is flown past the top of descent point, the message "Decelerate" appears on the PFD and MCDU. When Managed Descent mode is engaged, the aircraft begins an immediate descent at idle thrust. During descent, the aircraft may deviate from the vertical profile due to unexpected wind conditions or if anti-ice is turned on. In order to maintain the vertical profile, the aircraft speed is allowed to vary up to plus or minus 20 knots. This speed range is displayed on the PFD speed scale by a pair of half triangles. The nav display shows an intercept point symbol in blue to indicate where the aircraft is predicted to regain the computed descent path. There is also a vertical deviation symbol on the PFD altitude scale, which allows the pilot to monitor the descent. The scale range corresponds to the altitude scale of plus or minus 500 feet. The Prague descent page also indicates the vertical deviation from the descent profile.
If the aircraft becomes too high on the profile, select a speed higher than the upper limit if possible in an attempt to regain the profile. If the intercept symbol reaches the next level off constraint, the message, "More drag," is displayed on the PFD. Select 1/2 speed brakes in order to satisfy the constraint.
If the aircraft falls below the vertical profile, the speed will reduce to the lower limit of the speed range scale in an attempt to regain the profile. If this is still not sufficient, the aircraft reverts to speed mode. The thrust is increased, and the vertical speed is reduced until the aircraft once again intercepts the vertical profile. If a descent segment between two constraints is predicted to be impossible to satisfy, with 1/2 speed brakes extended, the message, "Too steep path ahead," is displayed on the MCDU, and all predictions between the 2 points will not be displayed. The open descent mode is a selected mode, which disregards all altitude constraints. It is engaged by selecting an altitude lower than the present aircraft altitude, then pulling out on the FCU altitude selector knob. The auto thrust sets idle thrust, and the aircraft begins an immediate descent, maintaining the managed or selected speed. The FMA displays idle open descent and ALT in blue, and on the PFD altitude scale, the FCU armed altitude is displayed in blue. The Altitude Acquire mode, or Alt-Star mode, uses an internal vertical speed program to capture the armed target altitude. Activation is dependent on the aircraft rate of climb or descent as it approaches the armed altitude. When within 20 feet of the target altitude, the Altitude Hold mode engages to maintain either the FCU selected target altitude or an altitude constraint if applicable. Caution: the Alt-Star mode vertical speed program has priority over the target speed. Therefore, if an engine failure occurs during climb in Alt-Star, a loss of airspeed may occur. Immediately disconnect the autopilot and level the aircraft to ensure a safe speed margin. 2 minutes after reaching the planned cruise altitude, soft altitude mode engages. This allows the aircraft to deviate plus or minus 50 feet in order to maintain the cruise Mach, thereby minimizing thrust variations and reducing fuel consumption.
Expedite is in open mode, which allows the aircraft to climb at green dot speed, the best lift to drag speed, or to descend at 340 knots, Mach 0.80. Expedite mode is engaged when the Expedite push button on the FCU is pressed. The aircraft will climb if the FCU altitude is set to an altitude higher than the present aircraft altitude, and will descend if the FCU altitude is set to an altitude lower than the present aircraft altitude. Expedite climb or expedite descent is displayed in the FMA vertical mode column. To cancel expedite mode, the preferred method is to pull out on the altitude selector knob to select open climb or descent, or to push in the altitude selector knob to engage manage climb or descent. Pulling out on the vertical speed knob to select vertical speed mode, or pulling out on the speed selector knob to select selected speed, will also cancel expedite mode. Expedite mode disengages automatically when the FCU set altitude is captured. Note: pressing the expedite push button a second time does not cancel expedite mode. The vertical speed flight path angle mode is a selected mode, which is selected by first setting, then pulling the vertical speed flight path angle selector knob on the FCU. The heading vertical speed track flight path angle push button determines which type of guidance applies.
In vertical speed mode, the auto thrust attempts to maintain either the managed or selected speed. However, the vertical speed mode has priority over the speed mode, and if the selected vertical speed or flight path angle is too high, the aircraft will accelerate or decelerate until a speed is reached where the vertical speed or flight path angle mode reverts to an open climb or open descent mode. The reversion from vertical speed to open descent is depicted here. There are a number of other conditions which will cause the aircraft to automatically revert to another vertical mode. These reversions are summarized in the chart. The autopilot flight directors have common lateral and vertical modes, which engage simultaneously on both axes. For takeoff, the common modes are the runway lateral mode and the speed reference system vertical mode. These modes are engaged on the flight directors during the takeoff run and initial climb. The runway mode has two submodes, runway mode and runway track mode. Runway mode is available whenever a localizer associated with the departure runway is tuned by the FMGC. It gives lateral guidance along the runway centerline during the takeoff roll and initial climb up to 30 feet radio altitude. The PFD displays the flight director yaw bar rather than the roll bar, and the FMA displays runway in the lateral mode column. The runway track mode automatically engages at 30 feet radio altitude as long as nav mode was not armed prior to takeoff. Runway track mode guides the aircraft along the departure track the aircraft was flying at 30 feet radio altitude after liftoff. The flight director displays the conventional roll bar and the FMA displays runway track. Runway track mode disengages when another lateral mode, such as heading, is engaged. If a departure SID requires a heading after takeoff, heading mode must be selected after runway track engages at 30 feet. The autopilot can be engaged 5 seconds after liftoff. The Speed Reference System, or SRS mode, controls aircraft pitch after liftoff to maintain V2 plus 10 knots with both engines operating, or in the case of an engine failure, V2 or the current speed, whichever is greater. SRS engages automatically when the thrust levers are set to a takeoff position, either toga or flex. The FMA displays SRS in the vertical mode column. The maximum pitch attitude is limited to 18 degrees nose up, and the minimum vertical speed commanded is 120 feet per minute. SRS mode disengages when another vertical mode engages, or when the aircraft reaches the cleanup acceleration altitude or the FCU altitude, whichever is lower.
For approach, the Autopilot Flight Director has common modes for ILS approaches and for managed non-precision approaches. The type of approach desired is inserted into the flight plan. To arm the approach push button on the FCU is pressed when on an intercept heading for the final approach course. For an ILS approach, the guidance modes are localizer and glide slope, and for non-precision approach, the guidance modes are approach nav for lateral guidance and final approach for vertical guidance.
The ILS approach includes the lateral modes of localizer capture, or LOC-STAR, and localizer track, or LOC, and the vertical modes of glide slope capture, or GLIDE-STAR, and glide slope track. The common modes are land, flare, and rollout. The ILS is armed by pressing the approach push button on the FCU panel. LOC and glide slope are displayed in blue on the second line of the FMA to indicate they are armed. The second autopilot may be engaged if desired. The fourth column of the FMA displays the approach categories, Cat 3 single with 1 autopilot on, and Cat 3 dual with 2 autopilots on, and all required systems operating. The MDA must be entered by the pilot on the perf approach page. The localizer and glide slope deviation scales are displayed on the PFD by pushing the ILS push button on the EFIS control panel. When the localizer is captured, LOC-STAR is displayed in green on the FMA, and when the localizer is engaged, LOC is displayed in green. When the glide slope is captured, GLIDE-STAR is displayed in green on the FMA, and when the glide slope is engaged, glide slope is displayed. The Autopilot Flight Director guides the aircraft down to 30 feet on the glide slope and localizer through the flare, touchdown, and rollout. Note, The glide slope cannot be captured before the localizer is captured. The localizer must be captured first. At 400 feet, land mode engages. The FMA indicates land in the Common Modes column of the FMA, indicating that the localizer and glide slope are locked, any selection on the FCU has no effect, and that flare and rollout modes will engage. Land mode can only be disengaged by engaging go-around mode. Below 200 feet radio altitude, with land mode engaged, the red auto land light flashes if both autopilots drop off, if there is more than 1/4 dot localizer deviation or 1 dot glide slope deviation, or if there is a loss of the localizer or glide slope transmitters or receivers. The auto land must be disconnected and a go-around performed.
At approximately 40 feet radio altitude, flare mode engages, and flare is displayed on the FMA. At 30 feet radio altitude, the autopilot flight director automatically aligns the aircraft with the runway centerline and the aircraft flares using elevator only. Auto trim is not functional. If the auto thrust is active, thrust idle is displayed on the FMA, and thrust reduction begins towards idle. At 10 feet, the auto callout system reminds the pilot to retard the thrust levers to idle.
Retard.
This action disconnects the auto thrust.
At touchdown, rollout mode engages and guides the aircraft along the runway centerline. The FMA displays rollout, and the PFD displays the yaw bar. The autopilots must be disengaged at the end of the rollout. Otherwise, when the steering hand wheel is used to steer the aircraft off the runway, the autopilot will attempt to steer the aircraft back to the centerline if the hand wheel is released.
The non-precision approach mode guides the aircraft laterally and vertically down to the minimum descent altitude. When a non-precision approach is contained in the database and selected into the active flight plan, pressing the approach push button arms the approach nav and final guidance modes. If managed lateral nav was already engaged, approach nav engages immediately. When the lateral guidance is engaged, the FMA displays approach nav in the lateral modes column, and when vertical guidance is engaged, final approach is displayed.
The vertical deviation scale appears when final is armed. Each graduation represents 100 feet deviation from the vertical profile. The final mode guides the aircraft vertically down to 50 feet below the MDA or 400 feet AGL if no MDA has been entered into the MCDU. At this point, the autopilot disconnects and the flight directors revert to the basic mode of heading vertical speed. The ground speed mini function takes advantage of aircraft inertia to ensure that the aircraft is flown at a safe margin above the stall in variable or gusty wind conditions. When the aircraft flies in approach in managed speed, the IAS target speed varies and is displayed in magenta on the PFD speed scale. The minimum speed that the aircraft will have at the runway threshold is VAP, the final approach speed. When the pilot enters the tower reported wind into the MCDU perf approach page, the FMGC automatically calculates and displays VAP. VAP is equal to VLS plus 5 knots plus a factor of 1/3 of the tower reported headwind component to a maximum of 15 knots. A tailwind component is not considered. In some aircraft, VAP is equal to VLS plus 5 knots or 1/3 of the tower reported headwind component to a maximum of 15 knots, whichever is greater. With the tower reported headwind component greater than 10 knots, the magenta IAS target speed displayed on the PFD speed scale is equal to VAP speed plus the difference between the actual headwind component encountered on the approach and the tower-reported headwind component entered into the MCDU. The IAS target speed can never be less than VAP, but there is no upper limit. In other words, any extra wind encountered on the approach is utilized to provide a safe buffer against wind shear while maintaining the same ground speed as that expected at touchdown. The ground speed mini function ensures that thrust levels and speed are maintained at safe levels. Two examples are shown. One has the aircraft flown at a fixed selected speed. The other utilizes the managed ground speed mini function. In the first part of the approach, the headwind component is less than the tower reported component, so in both cases, the aircraft speed equals the VAP speed of 140 knots. In the second and third parts of the approach, the wind initially increases 35 knots above the tower-reported headwind component, then drops to 0. In selected speed, the aircraft speed trend initially increases, so the thrust level decreases to as low as idle thrust in an attempt to bring the speed back to the selected target speed. The ground speed also decreases. However, in the ground speed mini function, the IAS target speed increases, so the thrust increases. The ground speed remains the same. In the third part of the approach, the wind drops off to 0. The aircraft in selected speed initially has a speed reduction, so the thrust, which is already low, must increase to regain the lost speed. The aircraft flying ground speed mini, however, is on the safe side of the speed scale, with high aircraft inertia. The thrust, which is high, has to come back. So in ground speed mini, unlike a conventional aircraft, with an increase in headwind, the thrust increases, and with a decrease in headwind, thrust decreases. Go-around mode is a combined autopilot flight director mode, which engages the SRS vertical mode with a go-around track lateral mode when the thrust levers are set to toga. The flaps lever must be in at least position 1, and the aircraft must be in flight or on the ground for less than 30 seconds. The FMA displays SRS and go-around track in green. The Srs Guidance Mode maintains VAP, or the speed the aircraft had at go-around engagement, whichever is greater. The go-around track mode guides the aircraft along the track the aircraft was following at the time of engagement. SRS mode is disengaged when another vertical mode is engaged at the go-around acceleration cleanup altitude, or when the missed approach altitude is captured. Go-around track disengages when the pilot selects another lateral mode above 100 feet radial altitude. The minimum height for the use of the autopilot on takeoff and go-around with SRS mode is 100 feet AGL. There is also an internal logic built into the system which prevents autopilot engagement until the aircraft has been airborne for at least 5 seconds. The minimum height at which the autopilot must be disengaged with Cat 1 displayed on the FMA is 160 feet AGL. For a straight-in non-precision approach, the minimum height for use of the autopilot is the applicable MDA. Recall that the autopilot will automatically disengage at MDA minus 50 feet if an MDA is entered into the MCDU approach page, and at 400 feet AGL if no MDA has been entered. For climb, cruise, and descent, the minimum height for autopilot use is 500 feet AGL. The use of the autopilot or flight director in open descent or descent mode is not permitted on approach unless the FCU altitude is set to MDA or 500 feet, whichever is higher. Nav mode is approved for use in the terminal area and for approach if the nav accuracy has been checked using raw data, or high accuracy is displayed if a nav accuracy check is not possible. For non-precision approaches, the use of approach nav and final modes may be used if the approach nav aids are manually tuned and displayed and raw data is continuously monitored for navigational accuracy during the approach. For ADF approaches, the approach ADF must be tuned manually. For a Cat 2 ILS approach, the minimum decision height is 100 feet AGL. At least one autopilot must be engaged in approach mode, and at least Cat 2 must be displayed on the FMA. If the approach is conducted without autoland, the autopilot must be disengaged at 80 feet AGL at the latest. The A320 is a fail operational system when both autopilots are engaged in approach mode and Cat 3 dual is displayed on the FMA. For a Cat 3 fail operational approach, the alert height is 100 feet. It is set by entering no into the decision height field of the MCDU approach page. The auto call-out system will then call 100 feet radio altitude. Below this height, a safe landing and rollout is possible, even with the failure of one of the required redundant systems. For Cat 3 without a decision height, the minimum runway visual range is 75 meters. If a decision height is required, the minimum is 20 feet AGL. If only one autopilot can be engaged, the approach capability is restricted to Cat 3 single. When Cat 3 single is displayed on the FMA, the A320 is considered a fail-passive system. This means that with the failure of one of the required redundant systems, the aircraft will not deviate significantly from the flight path or attitude, but the landing may or may not be completed successfully. Therefore, in the event of a failure, the autopilot must be disengaged and the aircraft landed manually. For a Cat 3 fail-passive approach, the minimum decision height is 50 feet. The auto thrust must be used in either selected or managed speed. For Category 2 or 3 automatic approach, landing, and rollout, the max surface headwind component is 30 knots in managed speed with auto thrust and 20 knots in selected speed with or without auto thrust. The max crosswind component is 20 knots and the max tailwind component is 10 knots.